So in this video, I wanted to go over one common mistake that I see a lot of students make. And in the other videos, I felt like I didn't go over this enough. So let me go ahead and address that here. So the first thing you have to remember is that under the area under a normal distribution for a standard normal, where the mean is 0, standard deviation is 1, the area is equal to 1. So the area under the shaded region is equal to 1 for a standard normal distribution. For a non-standard normal where the mean is not 0 and standard deviation is not 1, you can think of it as being 100% of the area under the curve, or 100% of the data values, right? So think of this area as 100% or the area is equal to 1, right? So now that's going to lead us to a problem where I see a lot of students make a mistake on this. So here the problem asks us to find the area under the curve. So we're trying to find the area under the shaded region, and we know we're going to use normal CDF, and we're also given that this is a standard normal, right? The mean is 0, standard deviation is 1. So let's pull out our calculator. So we know we're going to use normal CDF, the function normal CDF, to find this area under the curve. So we're going to press second vars, go to normal CDF. So the lower number is the leftmost point under the shaded region, which is 3.1. That's the leftmost point. And this shaves to the right indefinitely. So essentially, the upper is the rightmost point. So essentially the upper bound is positive infinity. But if you remember, we're just going to replace it. We're just going to put in a very large number like 9999, right? So the lower is 3.1. The upper, we can put 9999. Again, you can put something else, but a very large number like 9999 would always work. You just have to go far enough to the right. So the mean is 0, standard deviation is 1, and then we're going to click paste and press enter. So now this is where we get to a common mistake that I see a lot of students make. They fail to understand what this notation is. This answer, the area under here, is not 9.6767 and so on, right? That is not the answer. So the answer is not 9.6767.123 ... Now, you might say, well, why not? It's right here. Well, because, first of all, there's this e to the negative 4, and that's scientific notation. This is scientific notation. I'll explain how to deal with this in a bit. But the thing is, this cannot be 9.6767 because we had stated that the area of the entire thing is 1. So this surely cannot be greater than 1, right? An area under the curve cannot be greater than 1. So now, how do I deal with this? So this is scientific notation. The e to the negative 4 is essentially means times 10 to the negative 4. But I'll just go ahead and tell you the shortcut. Whenever you see this scientific notation, or a number of scientific notation on the TI 84 that looks like this, what it's telling you is we're going to move this decimal point 4 times to the left. That's going to be the number in standard notation, right? So the number is actually, if we move it 1, let's try it again. So 1, 2, 3, 4, right? And we're jumping over digits. We're just moving this decimal point by jumping under each digit. And wherever there's no digits, we're just going to put a 0 as a placeholder. So essentially, this answer, this shaded region, is 0.00096767 ... right? That's the number. So the number is, in standard notation, is 0.00096767.123 ... So now, in your homework, you're often going to be asked to round to a certain decimal place. So it's usually like round to the 4th decimal place or 3rd decimal place, right? So let's say we're rounding to the 4th decimal place. So that's going to be the round off spot. And then we're going to look at the 6 here, the digit here, to see if we're going to round this up or if it stays the same. So the 6 here is 5 or bigger. So this is going to be increased by 1, which means it's going to be a 10 and we're going to carry a 1 to the next decimal place. So we're going to put a 1 there. And that's the answer. So this is the answer rounded to 4 decimal places. Again, we cannot have an area greater than 1. So anytime you use normal CDF is used to find an area under a normal curve. You cannot get an answer greater than 1. And if you do get one, it's not because it's greater than 1. It's because it's scientific notation. Okay, so hopefully you found that helpful.